All right, we are live. So this week was Inference
Awesome.
for several means through ANOVA.
Yes.
Does anyone have any questions?
I did not, or I don't have any questions now.
No, I think I'm good too. Usually after we take the test, I read everything and I do the assignment, but it just doesn't sync until the end of the week. So we can just start the quiz if you guys are ready.
Sure.
Hold on. We're in lesson 14, right?
Yeah.
Yep.
Oh, okay. Hold on. Okay, yeah, that's what I thought. It's just that on the calendar it says lesson 13 for some reason, but I'm sure that's like, I mean, I have an app that like has all everything that's due.
What's the app?
The app is called Pulse.
Hey, I use that one.
Yeah, and for me it says that today lesson 13 group meeting quiz is due. And so that's why I was like, hold on, wait a second. But yeah, that I did that last week. So okay. Sorry. Yeah, we can start the quiz now. What's that?
Oh, I thought I lost you. I didn't hear you.
Oh.
Maybe you didn't say anything. So it's number 3. You reject HO when there is sufficient.
Yes.
Yes. Okay, so when the null is low, you reject, which means there is sufficient evidence. Okay.
So it's true?
Yes.
Yeah. And then whenever we fail to reject, we have insufficient evidence.
Insufficient, yeah. Okay. I think.
I know that the sample means are all positive.
And I'm thinking the variances are equal in each group, right?
Yeah.
Or is it overall?
I know I just watched the video again, or the lesson video.
Mm-hmm.
And it said, so it's right. Oh wait, no, that's for F distributions.
Oh, under 3.2 in the reading, it has the requirements. And it says there are 2 requirements that must be checked: that the data are normally distributed in each group, and that the variances are equal for each group.
So
Aren't the sample means don't have to be positive too? Or I think it's all 3, but I don't know. Let's see.
I don't know if it's the sample means that have to be positive.
It probably isn't. I think I got it mixed up with the F distribution because I just remembered from the video that it had a list of the characteristics of it. So it's probably
it's just the 2? Okay.
Yeah, I think it might just be.
Okay. I remember reading something though.
About positive. What was that?
Well, I mean,
I don't remember.
If you can control F, so if you just like search for positive in the
okay, I found it. The F just can't be positive.
Right. Or it can't be negative.
Or yes, it's supposed to be positive.
So that's just tricking me.
Yeah, that's in 3.1 where it says that. the values
Yes,
of
the F distribution.
Yeah. Okay. To check if each group is normally distributed, do the following. Construct a QQ plot.
Yeah,
Yes.
Oh, geez. These first couple of questions are not too bad. We assume the variance in each group is the same if the following happens.
it's
When
the
is it
largest
saying that?
variance.
Well, is it asking if they're the same or if they're equal?
It's the same.
If the largest variance is less than 4 times the smallest variance, right?
The variances are equal for each group. That's a requirement for ANOVA. This requirement is checked by examining the variances. The rule we use is if the largest variance is less than or equal to 4 times the smallest variance.
Yeah, so
Yeah.
that's the second one.
Yeah.
The ANOVA hypothesis test is equivalent to conducting independent 2-sample t-tests between every pair of samples. If there are 3 samples, there are 3 pairs. 1, 2, 1, 3, 2, 3. How many pairs are there when there are 4 samples? So 6. Let me think. No, let's see.
Okay.
Now, would it be 6?
Well, if you have 1, 1 and 2, 1 and 3, 1 and 4, 2 and 3, 2 and 4. Am I missing one?
This is...
1 and 2, 1 and 3, 2 and 3.
Well, okay, so there's 1 and 2. So there's all of those plus 2 and 4. 1 and 2, 1 and 3, 1 and 4. 2 and 3, and 2 and 4, and 3 and 4. So that's...
6.
Yeah, that's...
I got 6.
What I think it is.
Jody,
You
how
got
did you know
6?
that so fast?
I know,
I
she's
had to
I'm
go
like,
through,
huh?
like, I had to do all the pairs.
Yeah. Same.
I was guessing. Like, oh.
Okay, this next one uses the soccer shoes, and didn't we use that on our assignment?
I thought we did on the assignment, unless you already did the homework, because the assignment was the
No.
poet.
We used
No, just the...
poet.
Yeah, it was the
Yeah.
poet, the writer, and the novelist, something like that. The deaths, remember?
Oh! Oh, okay. I went through and did it. They used it in the reading, and I put it in just to make sure I would get the same answers.
So what is the minimum variance for the 6 groups? Huh.
Sorry, I don't know what happened. Did you get anywhere without me?
No,
Okay.
we're just
Good.
putting the data
Putting
in the
information.
yeah.
Okay.
And we put accuracy in.
Accuracy for what?
Wait, wait a second.
Oh, yeah, the accuracy, the numbers under the accuracy. And so they have a list, and you select all the A's and put them in the variable 1, select all the B's, put them in the 2.
Oh, right, of course.
It was kind of confusing when I saw it.
What about socks? Is that a whole nother one?
Yes, they want all 6 groups.
Oh,
so you'll
okay.
have 5 letters, and the variable 6 will be socks.
Oh, okay. I get it. Thank you for clearing that up for me.
Yeah, no problem.
So how many are there? 6, you said?
Yes.
Okay. I'm really slow. I'm only on 3.
Oh, that's okay.
I'm just about done. Okay. So what are we looking for? The minimum variance for the 6 groups.
Oh, gosh. I put in my third column, I put all C's.
Oh.
Oh, so smart. Remember how you said you shouldn't be in this class?
Oh, I think I've made my fair share of mistakes like that. Luckily, not recently, but that just means there are more coming.
Well, hey, we're like a little bit more than halfway.
Yeah.
On the quiz?
No,
Oh.
in the semester.
Class.
Yes. That's crazy.
It's all going to depend on this next test for me if I'm going to be able to pass.
Oh, I know. I don't know what I'm going to do because Josh helped me out a lot last time. Because after the homework assignment that I did terrible on and messaged you about over the weekend.
Oh, yes. Did he help you on that?
Well, the next time we met, we went over that assignment. And he, like, I don't know. I kept trying to figure out these crazy ways to find the margin of error.
Yeah, I don't get that either.
Yeah, that's like the one thing I don't understand is getting the margin of error. Like,
and then did you hear him? Oh, go ahead. Sorry, I didn't mean to cut you off.
No, it's all right.
No, you finish.
Well, it's like that's the that's the thing that I keep missing in the quizzes is like finding the margin of error of the 95% stuff. Like that stuff just, I don't know how to do it.
I know, crazy. So Leah, the meeting we had last night,
Uh-huh.
you notice how the girl, I think it was Amy, how she said you can just subtract. You know how Josh told us that?
Yeah.
And that finally clicked for me. I was like, oh, that's how we got it, like several days later. And then last night when we said he didn't want us doing it that way, right? Basically.
I think he said, yeah, you could do that, but I'd probably stick with the formula. And I've been doing the formula, and it never turns out.
Yeah, that's what I thought. I was like, no, the other one makes more sense to me. And if I get the answer right, that's how I'm going to do it. But I don't know.
Have you put in all the groups?
Okay, yeah, I finally got it done. So let's see, it's asking for the smallest.
Yeah.
So is that 27,208?
Yeah.
That's
208.
what I got.
Okay.
What's the maximum? Is the next question.
No, I like these ones.
53.158.
Yeah.
Do you guys have that one?
Yeah.
Awesome.
Yeah, I got. Okay, the test for equal variances is satisfied. Wait, the test for equal variances is satisfied for these data.
I can't remember how to get that.
Well, let's see.
The equal variances?
Oh, wait.
That's the one where you take the smallest and
Right.
multiply it by 4.
Right.
And I got true for that one.
Because that's 100 and something, right? If you take
Yeah.
the small. Okay.
Yeah, it's
so,
108.
So yeah, it would be true because the sign is a greater than sign, right? So you put the highest, whatever that is, 53.158 is less than, or is it greater than? You know what I'm talking about?
On which one?
No, you know how you find out, like I'm thinking of the video, like one of the videos where he's the guy on the chalkboard, where he said, where you put the highest, so the highest you would write 53.158. Is it greater than or less than the smallest times 4? You don't know what I'm talking about. Okay, it's true.
I kind of. I just.
No, it's if it's less than.
Less than. Yes. Okay. Okay. Sorry, I didn't mean to confuse you.
No, that's okay.
Construct a QQ plot for each of the 6 samples. Each of the samples are approximately normal based on what you see in the QQ plot. So true or false. Okay.
I went through and did all the QQ plots, and then I realized, and they were all totally scattered.
Oh, because you didn't.
And I realized that I hadn't put them in smallest to like the lowest to highest. I have to go back and do again.
Where do you find that the box plots? Are those on quantitative descriptive statistics?
Yes, and I just found that. I didn't even know they were here.
Yeah, I don't know either. But
so it's on, like, you know how there are different sheets?
Yes.
So it's there, but you can't see it right when you open it up. So you have to click on those 3 dots at the bottom, and then you'll see the QQ plots.
Oh. Oh my gosh. Well, I see QQ plots, but where's the box plots? Remember how our lesson says you need box? You have to show the box plots, right? Is that what they're called?
Is it
box plot?
Is that in quantitative descriptive?
Which one? The QQ?
Yes.
Yeah.
Yes.
Yes.
Okay, never mind. Let's just
I don't.
do QQ then.
I don't have that one opened yet, so sorry.
Okay.
That's okay.
Oh, there it is. Okay.
So far, they look normal. Is that what you're getting?
Yes, they're pretty close to the line.
Yeah.
Yeah. I'm gonna do the last one too.
So, what actually do you hold on? What do you post in the QQ plot thing? The data?
You have to go through. You know how we have the 6 variables?
Yeah.
You have to go through one at a time and put the numbers in. And then if your Excel sheet is full screen, towards the top right corner, there's a sort and filter. It has A and Z, and you need to sort them smallest to largest.
Oh yeah. Huh. Okay. Well, I'll look at that some time and study
They
that.
all looked pretty normal.
Yeah, I say we put true. Right?
Yeah.
Okay. If you perform an ANOVA test, those are repeated. Okay, so we just go over there and remove the socks. Was
Which is
socks the last one?
Yeah.
Okay.
Which changes the p-value to 0.309.
Sorry, I'm in my car and it's I'm in Layton, Utah, where the Air Force Base is.
Yeah.
Is that what you got? I got 0.309.
Oh my gosh, that's so loud. Yes, 0.309, right?
Yeah.
Okay.
13 is asking if the p-value is on the right or the left of the F statistic.
It's the right.
Isn't it on the left? Is it talking about the tail that was in the lesson?
That's what I thought. And so isn't it right?
Oh, okay. Yes, right.
Because it's right skewed, right?
Yes.
And that's why?
Right, yes, right skewed, but it would be on the left because, oh my goodness, it's right skewed, it's on the right. It's right.
It's really confusing. Right. Are you sure it's right? I don't know. That's
no, I'm sure it's right. I was envisioning right, but calling it left. So.
And I was just saying right because that's what it said in our text. Like I was thinking, right.
Yeah.
But I don't know if that's right. I don't know if right is right.
It is. I looked at the picture.
Okay. Oh, now we got to do a whole nother hot dog nutrition. Oh boy, I don't want to read this. I love hot dogs. Okay.
Let's examine the calories first. Construct QQ plots of the calories for each of the 3 types of hot dogs and compare the variances to determine if the assumptions to use ANOVA have been met.
So are we just testing to see if they're normally distributed with the QQ plots?
The QQ plots of the calories for each of the 3 types of hot dogs and compare the variances to determine if the assumptions Here comes another dang jet. Sorry, guys.
It's no problem. Adjust the calories.
It's safe to assume it comes from a normally distributed population.
Each type of Okay. Let's see.
Okay.
Why is there beef and then meat? What's the difference? Why is there just like a general meat?
Because I bet it's like the ones that have chicken, beef, the mixed kind of hot dogs.
Yeah.
There's mixed and there's beef and then there's different types.
That's understandable then.
I just know that because I like the beef ones better, and it helps me justify eating a hot dog. They're all beef and they're not like parts of a chicken and okay. Okay, so we're supposed to be checking the QQ plots, right? And
Yeah, and the variance.
and oh wait. I was gonna say they don't look normal to me, but hold on.
Nope, that's not what I wanted.
No. Hmm. Do you think they look normal? The second one was kind of more all over the place on the QQ plot. I mean, not all over, but kind of sinking down a little bit off the chart. Let's see. But what's interesting is sometimes in our homework, it'll do that and they still assume it's normal. Have you noticed that?
Yeah.
Like if it's close enough. Okay, so two of them look very normal to me. And it's just the one that's a little bit off. Is that what you think?
I thought they all looked pretty normal, but I'm the same as you. Like sometimes the lesson says they're normal and sometimes they aren't.
Yeah. Oh shoot, guys,
Uh-oh.
Is she gone?
I think she just turned off her mic and camera.
Oh, okay.
I'm not sure what happened though. Yeah, so the first one looked normal. Oh, no, that's...
hello.
Hi. What happened?
My phone died, so now I'm using my pad.
Oh.
Sorry.
That's no problem.
What did I miss? So we decided the QQ plots were normal. And what about the variance? Is that where we take the lowest, the highest and the lowest times 4? Is that what we do?
So the
I
lowest...
usually just take the lowest times 4 and then get my answer, and I'll look and just make sure that that the highest value is below
that
that.
makes more sense. So it's not, right? Because 5, 10, 15, 20. So it's, yeah. So it's lower. So what's that answer? You guys, let's see. Assumptions. Oh.
So there's only one answer that says the assumptions have been met.
Yeah.
What did you all get for your variances? Because there's only 3 variables, right?
Yeah.
Yeah. So those were 512.661, 2818.134, and 1431.958. So you got Leah?
Yeah.
Oh, I got something different. I might have done it wrong.
I
And
know
then
at
you just-
first I forgot to take off the variable 6 because I couldn't see it when I added everything in.
Oh,
Um,
Oh, I did do it wrong. Hold on, let me fix it real quick. I just didn't clear everything from variable 1. I was wondering why it was so much bigger than all the other ones.
okay, so they have been met, right, Leah?
yes.
Okay.
Okay. I think I got the right variables now.
And the variable 1 is going to be a little bit longer than variable 2 and 3.
Right.
Okay, so for that one,
So 15, is that where we're at now? I know the test determined the mean number of calories.
did we say that they were normally distributed? Is that what we decided?
Yes, that's what I. Yes, because the 2 looked normal, and there was one. The second one looked pretty much normal. You know how we were talking about sometimes in homework they might look off. They still. I don't think it was off enough to not count it. So I'd say yeah, normally.
So, I'm sorry, which one? So, it was, we can assume, well,
Yeah, so it's the first one, right, Leah?
that the assumptions have been met?
Yeah.
Yes.
Okay. Because, I mean, if that's the
Oh.
only, that's the only answer that has, that the assumptions have been met. So if the assumptions haven't been met, then it's
one of the other 3.
right.
I'm looking. I found some pictures of normal plots versus
Okay.
not normally distributed plots. And it looks like the data they all follow a curve. So I know some of ours, they just didn't all fit on the line. But on the ones that they're showing for skewed left and skewed right, they, all the points are shaped in a curve. So maybe that will provide greater clarity. So for 15, isn't it, we have sufficient evidence to claim that all 3 hot dog types have a different mean number of calories? Third one down. Or is it we have sufficient evidence to claim that at least one of the hot dog types has a different mean number of calories?
Well, yeah, because variable 1 and variable 2 are they're pretty close to each other. So does that, I mean, because the other one is, variable 3 is 40. Their mean is 40 points different. But I'm not too sure, unfortunately.
They have both examples in the lesson.
Yeah.
Where they say there is sufficient evidence to suggest at least one, and then sufficient evidence to all 5. Or not all 5, but all variables.
Aye. Let's see.
I don't know. I remember it's out of my mind, but I don't know.
Well, the alternate hypothesis states that one or more of the means differs from the others. And that's the same alternative hypothesis for every problem.
Right.
So we didn't do all three, because that's not what the alternative hypothesis. Is it alternative or alternate?
I think it's alternative.
Okay.
Alternate?
Alternative, you were right. So would it be the last one?
We have sufficient evidence to claim that at least one of the hot dog types has a different mean number than another. Does your lesson say math processing error on your it?
It did. I don't know if you need to refresh the page.
Yeah, I'll just refresh it real quick. Oh,
I'm not sure when it does that to me.
no.
But sometimes I go back and it's like that.
Oh, now it's fixed.
Okay.
I was wondering,
Good.
like, give me a second. Okay. Huh. You should find that it's perfect. Yeah, of course. What conclusion can you draw? Yeah, I think that one. I think we have sufficient evidence to claim that at least one of the hot dog types has a different mean number of calories than another type. And it's at least one. But,
I'm just not totally sure. Well, okay. I am on the sodium one because we need to do the same thing but with the sodium numbers from the hot dogs. And I know the variance is okay, but I don't know about the normally distributed population while looking at QQ plots.
What said right in the, did you see that right in the problem? It says you should see that the QQ plot for poultry suggests a possible problem with the normality assumption. So we're supposed to notice that. Let's see.
Oh my goodness, so do we not even have to do QQ plots for the whole thing?
I think we do, but it's just saying you'll notice.
Okay.
That's why I want to do it, because I want to see what it's supposed to look like when there is a problem.
Yeah. Well, I think the variable 1 and variable 2 look okay. But when I got to variable 3, that's when it looked weird.
Let me do that one. I've only done one. Let's see. 3. So that's the poultry. Okay. Yeah, that one's not, because there's 3 little dots to the far left, right, by number 1.
Yeah.
Yeah, so that's definitely not normal. Okay. Let's see. And the smallest variance is 7180.75, and the largest is 10,492. So you take this, what'd you say you do? Yeah, you take the smallest and flip by 4.
Yeah. And then I'll check the highest, and I mean, it can be kind of obvious to tell, like you have 7,180. Well, if you times that by 4, you're going to be getting 2,800 something, or 2,000. No, 28,000. There you go.
Yeah.
And that's over 10,000, which is the highest variance.
Okay, so that means they're not,
Right.
this has not been met. The assumptions have not been met. Well, it is.
Yeah. All the answers say that the assumption has have not been met.
Okay.
The assumptions have not been met. It is not safe to assume each group comes from a normally distributed population, but we can assume that the variances are equal.
Oh, gosh. But the first one's not true because the QQ plots were off, right?
Yes.
So let's see.
So the first and second one are not true because the QQ plots are off.
And we're not normally distributed, right?
Yes, but the variances were still equal.
Yes.
So the third one down. Is that right?
Yeah.
Yes.
Despite the possible problem with the QQ plot for poultry, we decide to use ANOVA to determine if the mean sodium levels are the same for all 3 groups. What is the p-value for this test? Isn't it 0.179?
That's what I got.
Yeah.
Sorry for cutting you off there, Jodene.
No, 0.179.
Yeah.
Okay. Yep.
What conclusion can you draw about the mean sodium levels of the 3 types of hot dogs? The alpha is 0.05, which means that we failed to reject the null hypothesis.
And we do not have sufficient evidence, right? Wait, we have sufficient. When you don't reject, you do, wait. Oh. When you do not reject, you have sufficient, or we do not have sufficient?
What conclusion?
Not, right?
Well, I would have said we do not have sufficient evidence to reject the claim that all 3 hot dog types. So that's just rejecting the null hypothesis. Right?
Right. Okay, so when
or do we have sufficient evidence?
So when the P is low, you reject the null. But this P is high.
Which means we fail to reject.
Yep.
Right.
And when you fail to reject, you do not have, right? Sufficient evidence?
If we fail to reject, it means we don't have sufficient evidence, or we don't have enough evidence for the alternative hypothesis, which would be that there is a difference. But they don't have that as an option.
Yeah.
So I would say it's one of the first two. We have insufficient evidence to reject the claim.
Right, so it would be the second one, since we do not have sufficient evidence.
I think it's the second one, but I don't know.
But that was restating the null hypothesis, not the alternative. It says that all three hot dog types have the same mean and not the different. See, if it says we do not have sufficient evidence to reject the claim that all three hot dog types have a different mean of sodium levels, have different means of sodium levels, that
What the?
would it be the first one then, since we failed to reject the null?
Yeah, sufficient.
I'm sorry, I'm not very much help.
Should I try it?
I thought it was that one just because, but now I see the thing. That's only when it's
Well, let me
the other.
see. I'll submit my quiz and just see what I got.
Okay.
And then if we got it wrong, or even if we got it right, we can just talk about what the answer was.
Right.
Okay. All right, I'm going through really quick. Okay, so 18 was wrong. I put the first one, that we have sufficient evidence to claim.
Is that the only one that we missed?
Yeah, we got all the others right. So I don't know. We do not have sufficient evidence to reject the claim.
I'm going to put that,
Okay, that does make sense. Except I feel like we got okay, no, we didn't get the evidence. We didn't get the evidence.
So is anybody going to feel bad if I submit mine and that's how we did it last time?
No, I think we talked about it. We discussed it.
Yeah. No, I won't feel bad.
Oh, I got one wrong. Which one?
Which one?
Oh, I got 18 right. So it was we do not have sufficient. What did I get wrong? Oh, I got question 8 wrong.
Hold on, let me see if I may have skipped over it. For 8, we put 27.208.
Oh, I didn't put the 2. I put 27.08. It was just and I have written down 27.208. I just did a mistype. Okay, so it was that 18 is that one.
That we do not have.
We do not have sufficient evidence.
Yep. Huh.
I think it's just trying to confuse us.
Yeah.
I think this whole class is just trying to confuse us.
I can see that. All right. I'm going to stop the broadcast now.
Okay. Yeah, and I have one.